reaction? Sorry, I should have started. Why will it favor the exothermic reaction? Yes? Yes. Which will tend to warm up the reaction mixture. Okay. In this example, which one is the exothermic reaction? The reverse reaction. So that means that for this one, so you start off with decreasing temperature will favor the exothermic reaction. Then you say it is the reverse reaction that will be favored. So what will happen to the equilibrium? The equilibrium will shift to the, so you're cooling this whole thing down and the reaction will try and heat it up again. It won't manage it, but it will try to do it. So the equilibrium will shift to the left because the reverse reaction is the exothermic reaction. So you'll have more crystals forming. You'll have more of these sodium chloride crystals forming. And what will happen to the concentration of the ions? They will decrease. They will decrease. That's what it means when they say the reaction will shift to the left, because then there will be less sodium ions and less chlorine ions in the solution, and there will be more sodium chloride crystals out of solution. Are you happy? So decreasing temperature makes the salt less soluble. There'll be less salt, there'll be more crystals and less ions in solution. So decreasing the temperature makes the salt less soluble.
It doesn't speed up the reaction.
It slows down the reaction. Both the forward and the reverse reactions will slow down. Now we need to ask, who will slow down most? The endothermic reaction will slow down most. Yeah. And it's always like that. Look here in this graph where we increase the temperature. It's the endothermic reaction that shot up higher. So now the endothermic reaction will shoot down more. Both will slow down, but the endothermic one will slow down more. I'm going to draw it on the PowerPoint so that we can record it.
Ma'am, going back to this graph, sorry ma'am. The increase of temperature is in the favor of the forward reaction, which is the endothermic, right?
Yeah.
According to the principle. Yes, ma'am. which speeds up both of the reactions.
Yes.
But
Everything will go faster when
Yes.
it's hotter.
But between the two reactions, the forward reaction will speed up the most.
Yes, the
Since
endothermic
it's
reaction will speed up
Since
most.
it's in the favor of the forward
In,
reaction.
well, it depends on how how this equation is written.
So can I say
Because
endothermic?
if I swap the chloride and the sodium chloride around, then it would have been the reverse reaction. So you must always look at which reaction is the endothermic reaction.
So I must write endothermic
It's
instead.
Instead of forward, you first write endothermic and then you write forward.
Oh, I get it. It speeds up both, but
Yes.
one
The
reaction will
endothermic
speed-
one
so
speeds up most.
Since it's in favor of the
Mm.
condition, which is the increase of temperature or decrease in temperature.
Mm.
Oh, okay, I get it.
Okay? Can I go away from this slide to the graph slide?
No.
Not yet. If we look at the rate graph, once you've got your initial equilibrium, so the rate of the forward reaction will decrease and the rate of the reverse reaction will increase. Okay, so this is the rate against time graph, and this is the rate of the forward reaction slows down. And the reason for it slowing down is the sodium chloride salt crystals will be less. The less there are, the less the speed of them dissolving. And your reverse reaction speeds up because there'll be more sodium ions and chloride ions in solution, and the more there are, the faster the reverse reaction will be. Then it reaches equilibrium, and if you keep the temperature constant, that equilibrium rate will stay like this. This must happen at a constant temperature. Okay. Now we are looking at changing the temperature, and we said we're going to drop the temperature. That's what we're looking at here. So dropping the temperature makes everything go slower. You're cooling it down. So the solid line will drop and the broken line will also drop. But who will drop more? Yes, the endothermic reaction. And in our case, the forward reaction is the endothermic reaction. So the endothermic reaction becomes even slower. That's why it drops so fast. Now a new it's a lower temperature, but now it's a constant lower temperature. Coming. It's a constant lower temperature. So to establish the new equilibrium, the whole reaction will be slower. The forward reaction must speed up again, while the reverse reaction will slow down again. Okay, so a new equilibrium at a lower temperature. The new equilibrium is at a lower rate when the temperature is decreased. Use I want us to use the same example, but look at what will changes in concentration do to the equilibrium. I'm just, for the sake of people watching, will rewrite the equation. So we discussed it this morning. If you have a solid, the concentration of a solid can't change. So once we've got a saturated solution there in that conical flask, even adding more salt will not make them go into solution. You'll just have more salt crystals in that conical flask. Okay? So there is no sense in adding sodium chloride salt crystals to a saturated solution. It will not change anything to the dynamic equilibrium by adding the crystals to the solution, because you can't have more dissociation taking place in a saturated solution. The forward reaction is still endothermic, but take the heat, only temperature will affect endo or exothermic reactions. Okay. Right.
Now, in the saturated solution, right, that's where the
No more salt crystals can dissolve.
right, due to its condition.
If the temperature is kept constant, then the rate of the forward reaction equals the rate of the reverse reaction.
So, ma'am, if we add more crystals into our solution, into our saturated solution,
At the same
Nothing
temperature,
will
nothing will happen. No.
if we would increase, then it will
If you will
dissolve.
increase the temperature, then the forward reaction is favored,
Okay.
and more of the salt will dissolve.
Yes.
Okay. So I want us to look at changes in concentration. This morning we started talking about it. We say you add, our situation was you add hydrochloric acid. Now hydrochloric acid solution has chloride ions in it. So it means that you're adding chloride ions. You're increasing the concentration, square brackets around the chloride ions mean concentration of the chloride ions. Now we need to look at Le Chatelier's principle. Le Chatelier's principle. What will happen if we increase the concentration of the chloride ions? Automatically, which reaction will be favored? You're adding, so I'm trying to say you're increasing this concentration. I'm not trying to say this is a gas. I'm trying to say you're putting more chloride in. Which reaction will be favored? The reverse reaction will be favored. Le Chatelier's principle says the reaction that will oppose the change, that will oppose the increase in concentration, will be favored. So Le Chatelier's principle says the reaction that will decrease the concentration of chloride ions. In other words, that will use up. This added chloride must now be used up. or they try to use it up. They won't use it all up, but they'll try. So Le Chatelier's principle says that the reaction that will decrease the concentration of chloride ions will be favored. And that is the reverse reaction. Alright? So the reaction will shift to the So what will we see? We will see more crystals forming. We'll see more sodium chloride crystals forming. And what will happen to the concentration of sodium ions?
It will increase.
Why?
So it will stay the same.
Why? Because you're favoring this reaction. You're favoring this reaction. It's favored. How can sodium be untouched? How can these sodium ions be untouched?
Because we're changing concentration.
It must change. Because this one is married to that one. So they start clinging together. They come together, those two, and they make NaCl.
So it will increase.
They won't increase. They're used up. It will?
It's limited.
It will decrease. And what will happen to the concentration of the chloride ion? It will also decrease. When the reverse reaction is favored, both the sodium ions and the chloride ions will go out of solution. These two things work together. If the reaction will use up the chloride, it takes the sodium with it to make NaCl crystals. So you've got some blue balls and some green balls. And you must have a few of them. And for every blue ball there must be a green ball. And they form a crystal lattice like this. Nice, oops, you've got your nice sodium chloride crystal. So all the blues are sodiums and all the greens are chlorides. Okay, go, go, go. Very slow. Alright, so you mix it with water. So you've got water. But you must have more than enough of these crystals so that you will build a saturated solution. Okay. The moment you put them in the water, some of these blue balls goes into solution. And the green balls. For every blue ball, there'll be a green ball going into solution. So let's say we start there. And we carry on to build a saturated solution. So for every chlorine ion, there'll be a sodium ion going into solution. Okay? And we'll take another sodium and another chlorine away from this. And we carry on. It has not reached equilibrium yet. So for every sodium ion that goes into solution, there'll be a chlorine ion that goes into solution. So I need to take away my sodium and the chlorine from my crystal. You need to model that. Every time from your crystal, you take two balls, a green ball and a blue ball, and you put them into solution. So, for a green ball, there'll be a blue ball going into solution. So your number of green balls and your number of blue balls that are freed up must always be equal. So I'm eating away on my crystal, the ions are going into solution. So another green one, another blue one will go into solution. So I need to take them away from my crystal. Must I continue a little bit more? So I'm going to take another green and blue one away and put them into solution. So you should be having some balls still stuck together in its lattice, and some, for every green ball there must be a blue ball in solution. Okay. Now, if the chlorine or the chlorides are the green balls, you now need to add hydrochloric acid solution to this. So what is going to happen? You'll have more chlorines, and for every chlorine there'll be a hydrogen as well. I'm putting a stranger in here. There's a hydrogen for that chlorine, a hydrogen for that chlorine, hydrogen for that chlorine, but it's all freed up now. They are ions that are in solution. So now, once I've reached the equilibrium, if I add more chlorines, what will the reaction try to do?
It will use up all this sodium.
It will try, yes, it's possible, but most likely it won't, because a new equilibrium will be reached before that time. Not all the ions will be used up. So put some extra green balls into your solution. The extra green balls in your solution will now come together with a sodium to make another part to the crystal. So you're building back on your crystal. And another chlorine, because you put extra chlorines in, the extra chlorines will use some of the sodiums and it will build back into your crystal. That's what's going to happen. Will all the sodiums be used up? Most probably not. But the concentration of the sodium ions in the solution will decrease with the chlorine in the solution. So you'll still have extra chlorine because you can't use them all up. So adding the chloride ions will use up some sodium.
Why some?
Because it will never finish all of them. It can't finish all of them because you're in a dynamic equilibrium. The forward reaction continues taking place. It never stops. It's just difficult to do it with the tools I've got. Yes.
Okay, at the product side then, the increase, after we added the hydrochloric acid, the increase of the chlorine has increased. The concentration of chlorine has
increased, yes.
Now,
the reaction will try to decrease it. Will it be able to use up all the extra chlorine? Most probably not. But it tries to decrease it. And with it, the sodium ion concentration will also decrease. And you'll have more crystals forming.
that's all that's yes. Ma'am, because there's an increase, ma'am, in chlorine, right?
Yes.
So, ma'am, if it's going to be in a reverse reaction,
Yes.
it will increase the sodium chloride.
The reverse reaction is
This
favored.
is favored. This is, okay, originally,
So,
this is a,
the reverse reaction will be favored and more sodium chloride crystals will form. There will be more of the salt crystals forming. Yes. Okay. I want to picture now. Okay. So we have a reaction at equilibrium, and it is our sodium chloride salt is in equilibrium with the sodium ions in solution and the chloride ions in solution. Now when we added hydrochloric acid, we increased the concentration of the chloride ions. It puts more chloride ions into the solution. The reaction is unhappy about it because you're disturbing the equilibrium, and it shifts the equilibrium to the left. It speeds up that reaction. The reverse reaction is sped up. It speeds it up, goes much faster, and the forward reaction will then lag, but it will also speed up slowly in the end. Okay. Let's add another chemical, silver nitrate. Now, when you add a silver nitrate solution, that silver grabs onto the chloride ion. The silver ion will grab onto the chloride ion, and it will form silver chloride solid. It's taking the chloride ions out of solution. So the silver ion takes the chloride out of solution. What's this reversible reaction going to do? It will oppose that. What is it going to do? It can't do anything to the silver chloride, but what can it do? It will break up more sodium chlorides to make chloride ions and sodium ions. So which reaction is favored? The forward reaction. So adding silver nitrate removes Cl negative from this solution. So it's disturbing the equilibrium. And Le Chatelier's principle says the reaction that favors the making of more Cl negative in solution will be favored. So the forward reaction is favored. Okay, so the equilibrium shifts to the yes.
And this is the show the previous slide.
Yes. So this equilibrium will shift to the right. What will happen to the amount of crystals?
It will decrease.
Will decrease. What will happen to the concentration of the sodium ions?
It will increase.
Yes.
So
Now you can never replace all the chloride ions, that will be taken out. But the concentration of the chlorine ions will also increase because you're favoring the forward reaction, the making of the chlorides. But it's like you said, you can never replace everything that was taken out. But a new equilibrium will be reached. Are you happy with that?
Kind of, yes.